We're going to go ahead and get started. I want to welcome everyone to Flood News at Noon today, and I'm going to introduce our guest speakers. First, we have Daniel Price, who's the managing principal for Keystone. Daniel's roots in the insurance industry go back over 2 decades, when his father began a career as a catastrophic insurance adjuster. As a teenager, Daniel traveled with his father adjusting property claims throughout the USA. When Hurricane Katrina hit in 2005, he became an independent adjuster, and over the next decade, Daniel became a top producing wind and flood claims specialist with an average closing ratio of 3-to-1 claims to his next closest peers. While immersed in the claims industry, Daniel started looking for additional ways to grow and realized there was an absence of forensic engineering firms operating with the same urgency and standards expected of adjusters and adjusting firms. In 2015, Daniel formed Keystone Experts and Engineers, and because of Daniel's knowledge of the claims process, he was able to create a unique business model that enables Keystone Experts to investigate claims throughout the country and produce a solid, accurate report much faster than industry standards. In April of 2015, a large hailstorm hit the entire coast of Texas, and within 30 days of its inspection, Keystone was accepting more volume and completing reports quicker than the industry leaders that have been around for decades. Since then, Daniel has led the exponential growth of Keystone, which now provides engineering services in every state, even Puerto Rico and the U.S. Virgin Islands, to over 100 clients annually, both national and regional. We also have Jason Rasky, who is the account executive for Keystone. Jason develops and maintains healthy working relationships with Keystone's clients, manages the building consultant team, and directly oversees the litigation requests that Keystone is engaged in. Jason has worked in the insurance industry for 18 years as a claims manager and corporate expert. He brings a wealth of industry knowledge to Keystone to continue its growth as a solutions provider. He is dedicated to customer experience and drives his team to understand the importance of customer experience, both for the clients and their customers, all while maintaining the lowest cycle times and providing high-level reports our clients require. Please welcome Jason and Dan.
Thanks, Julie.
Thank you, Julie.
Thanks for having us. Always loved working with you guys, and appreciate what you guys do. Watched you guys grow exponentially as well over the last few years. So it's been a fun ride together with lots more years to come. Thanks everybody for joining. Got a pretty jam-packed little presentation here. It's one of those things that's really important to understand as a flood adjuster. You know, with Jason and I's background being in the flood industry as long as we have, and you know, these are things you wrap your head around this. It'll really help the claims cycle and the claims process go a lot faster, especially when it comes to, hey, when you need to, you know, engage an engineer on these types of topics. So with that said, Jace, can you share your screen?
I cannot. It says I am unable. Julie, oh, here I can now.
Boom.
There I am. Let me see. We put it in our presentation format. Boom, here we go.
Go back to the
top. There we go.
There it is.
So welcome.
Go ahead.
Welcome. Thank you for having us, CNC. We appreciate the opportunity to present here and chat with you. I know a lot of you already know us and know Keystone already, have engaged us in the past, so we appreciate that. And those who have not, a little bit about us. We have nationwide coverage. We have structural engineers around the entire country. We have probably over 300 experts now, I think, plus. I think we're still continuing to grow, so we may even have more at this point in time. But heavily involved with the structural engineering across the country. If you need a mechanical engineer or electrical engineer, we have those as well. Building consultants, we have those, and general contractors around the country utilize. And getting involved with the fire investigation. Dan's developed a team now, and we have nationwide coverage for our fire investigation. One fact that Dan mentioned just a minute ago, and why he opened Keystone, was to provide a better customer experience for our clients and customers. Like claims, they tend to take some time, but Dan formulated a process, and we have a process here now that we're able to turn around reports within 15 days from we get a green light. So if we remove the PA assignments or PA attorney rep assignments, that would probably be a lot less than the 15 days. So doing well here, and appreciate the opportunity to present to you guys today. And today we're going to cover causation of structural damage following a flood. So we're going to talk about some of these topics here, and Dan's going to kick it off with the hydrostatic forces. That's what we experience, and our engineers are heavily involved in after a flood.
All right, well, thanks, Jason. So, you know, why this is so important is, you know, as you guys are claims adjusters, if you're experienced or not experienced, you get out there and everybody says, well, it wasn't like this before the flood. And they may not be lying, actually. They may actually be telling the truth. But just because flood did it, that doesn't dictate whether or not you're going to be able to pay for it, or whether or not, you know, it was directly related to the flood or was indirectly related to the flood. So where all these forces come in when you talk about hydrostatic forces, hydrodynamic forces, buoyancy forces, and then you've got erosion, you've got scouring, then you've got inundation, you've got all these different things that we're going to talk about today. All these things matter because while they're all related to flood, what the key part is, and what we do as, you know, an expert firm, is defining what aspect of the flood did it. You know, was it a force of the flood? Was it an indirect result of the flood? You know, all those types of things. Was it an ongoing thing? Was it the straw that broke the camel's back? There's all these different factors that you have to look at before you can just say, oh, well, the flood did it, you know, so therefore it's, you know, it's either covered, not covered, or, you know, however you want to look at it. You know, because the homeowner doesn't know. I mean, and they're not supposed to know. You know, you guys are there to guide them, get them through this process as painlessly as possible, you know, in an already stressful, hard, you know, situation. So when we start looking at this stuff, you know, we're going to start with hydrostatic forces. We're going to talk about that. We're going to go into the difference in that between hydrodynamic forces. Then we're going to talk about soil inundation, differential movement of soils, settlement, which is the most common thing you run into when you look at slab cracks, wall movement, things like that. And then one thing that, you know, isn't as common, but honestly pretty complex, because it's got some nuances, which is the mud flow versus landslide. So it's gonna be kind of fun. Like I said, we're gonna try to keep this as high level as possible. This presentation, I mean, literally, you could take any one of these and make a whole entire class out of it. So we just want to give you enough to be dangerous today, to kind of wrap your head around it and go from there. So see there, hydrostatic forces. Hydrostatic forces are forces acting on a foundation wall that are caused by a difference in pressure between the inside and the outside. Now, that's typical engineer speak, so we're going to make it a little bit simpler. So go to the next slide, Jason, and then we can kind of break this down so it actually makes a lot more sense. So it's all about pressure. You know, think of it this way: you've got a house, you got more water, you know, interior and exterior water lines, right? Quite often, the exterior water line is, you know, higher than the interior water line. A lot of times it's pretty close to the same. You know, sometimes there's a little bit more of a difference, but for the most part, it's always going to be a little bit higher on the outside than it is on the inside. And that's because, well, it's got to get through the walls. You still have vapor barriers, you still have building construction. And depending on how long that water actually stuck around and what velocity, what force it was flowing by, can dictate how much water actually gets in. You got a house that's pure CMU walls. Well, those things are porous. You know, your water level is going to be pretty much staying the same on the inside and the outside. You got a brand new house that's dried in, awesome, you know, insulation, vapor barriers, all these things. You might have a much larger discrepancy in what it is outside versus inside, especially if it was a fast, you know, more rapidly happening flood. So how hydrostatic works, and think about static versus dynamic. Static is static water. It's not flowing water. So you have higher water on the outside or higher water on the, you know, or lower water on the inside. And so now all of a sudden that discrepancy, if it's big enough, those walls, you guys have been in the ocean. You know what water pressure can do. It doesn't take a lot of water to do things. So you got a 5-foot difference in water on the outside versus the inside. That is a substantial amount of pressure, on a building and acting on a building. And then you also have pressure coming up from the ground, and so that could be static, hydrostatic pressure coming up from the ground, and that can put force on the slab and force on the footers, force on the walls, those types of things there. So again, increased pressure on walls and floors from the addition of water, in the area, around the area. The longer that water sits, the deeper the penetration is into the soils, the greater that pressure may be exerting on the front. And again, how dried in the house is, how dried in it's not, it all those factors come into play. Go ahead and go to the next slide, Jace. All right. Another part of hydrostatic force is you've got the buoyant part of those hydrostatic forces. Buoyancy is simple. Wood floats, right? You throw wood in water, it floats. A lot of building items float. Slab doesn't float, but you get into these pier and beam homes, you get into these, elevated homes, their foundation systems are wood, right? If they're not attached properly, if you've got, and they're older, hurt straps and all those things are rusted out, who knows? You can easily have buoyancy from up underneath. That buoyancy can create the displacement of the property. It can lift it, reset it back down. It can mess it up from one side, other side. But that is an aspect of hydrostatic, because it's just the natural buoyancy of an object to float, when it gets in that water. So again, you have a long-standing lake effect, ponding type effect, flood event that's acting on, an older home, say it's built in the 80s, and it's a pier and beam, it sits there for a lot longer. That's going to have a lot more tendency to potentially raise up, potentially come off of its foundation, just depending on how it's constructed. But buoyant forces are the vertical pressures applied to the structure due to the vertical water pressures. Again, vertical water pressures coming up from underneath, and it occurs when the weight of the displaced water immersing the structure is greater or equivalent to the weight of the structure being displaced. And a lot of that has to do with how buoyant the actual object is that it's trying to displace. There's certain objects that are more and more buoyant than others. Go ahead and go to the next slide. So then you get into how do buoyant forces affect structures. Kind of talked about the raising houses. Well, one of the most common things you'll see is in pools. If a pool is not full and you have a flood event in the area, that pool can and will come right up out of the ground. You see this in freezing actually as well, in areas where, there's just a big freeze thaw event and a pool's not frozen. People drain their pool for the winter, not knowing that they're actually supposed to keep water in it all winter. That pool will come up out of the ground. We've had several assignments like that, just trying to determine the cause and the origin of, hey, why is this pool up out of the ground? But in a flood event like this, you get a big one. That pool is a big, huge fishbowl, and it's not full of water. Guess what? that thing's going to go up. But that's the same principle of what it can do to a house if the house isn't, constructed and tied down properly. Next. Little simple table here. What is water pressure? Hey, in a typical dry event, if you look down on the bottom left, you've got the water table, which is down there. And then all you have exerting on the structure is earth pressure. That's it. And you're going to have typical expansion, contraction of soils, depending on what area of the country you are in. That can be really bad to, very minimal, depending on how the quality of the soil, right? And then now all of a sudden you've got this raised water table. Well, not only is the earth pressure acting on it, which is now increased, now you got the earth plus the water pressure coming on it, which is driving that whole instance up. So you could have a heaved slab in the middle of a house. This is due to that type of hydrostatic pressure acting against the slab underneath, just because you've got the combination of earth and water pressure. Not all heaved slabs are due to just straight up earth movement or, soil expansion. A lot of heaved slabs, could easily be due to hydrostatic pressure, but you really got to look at it and look at all the other factors to see, hey, does this add up? Is the slab heaving enough that it adds up or little? You put it all together, and that's what the brainiacs and the engineers are for. they put all that stuff together. How does water pressure affect structures? Again, this is pretty common. This is what you're going to see most commonly in an event like this. Is you're going to have these lateral earth pressures, these lateral water pressures coming at it, and it's going to just buckle that interior wall. This could be a subgrade thing. You see this a lot in basements. Again, you see it a lot in older homes that were constructed at a CMU. They might not have been reinforced. They didn't have the rebar coming down. That just older construction practices. They weren't designed to withhold the type of lateral pressure coming in on those walls, and so you see this a lot in basements. And you can see a lot. You can see it in the upper floors as well. But the most common area is in a basement, because you've got all this earth pressure already acting on it, just naturally. And then now all of a sudden you've got all this water, and these walls weren't meant to be retaining walls. They were meant to just hold back the earth. And now all of a sudden you're telling them to retain all this water as well. They buckle under pressure, boom, you're going to start to see those failures. And you can, you've seen them all the way blown out to just, similar crack. And I think we've got a couple pictures here that kind of show that next too. Yeah. So identifying damage, you got walls bowed or offset inward, diagonal cracks at the wall corners, pumping water at cracks, gaps in the floors. I don't know if you guys have ever been in a flooded home in the basement, or even just a typical slab on grade home. I mean, water is still coming up. Like, you can see it gurgling up through the, through the surface, depending on how quickly you got there. And that's all hydrostatic pressure coming up from the ground and from the sides. Horizontal cracks in the field of the wall, stains on the walls beneath the cracks, upward heat of the floor slab. All of those are hydrostatic water pressure. I mean, again, this can messes things up. And you can tell, the better you get, the more experience you can tell what's older, what's newer. We get into stuff, involved in stuff all the time where, hey, this crack existed before, it was already failing. Well, now you got this big flood event and it's really failed. And that's where it gets even more complicated, because we have to look at it and say, hey, how much of this is new? How much of this is due to the flood event only specifically versus how much of this was pre-existing? So, our engineers get involved in that. They can give you a pretty definitive answer on, old versus new, so that you can apply the proper coverage, the proper percentage. Go ahead, Jason. So now getting into hydrodynamic, as discussed, static, standing still, standing water. Now all of a sudden hydrodynamic. Dynamic is moving water, dynamic flowing water. This is the velocity flows. This is the wave action. This is the pressure exerted on all of those things. Hydrodynamic, notoriously is probably a lot more damaging than standard hydrostatic, just depending on the area and the characteristics of the flood event. But a river overflowing its banks, flowing really fast, hydrodynamic. A hurricane, massive waves acting against a structure, hydrodynamic. So this has the ability to create a lot more damage a lot quicker than hydrostatic does. So what is hydrodynamic? Hydrodynamic forces occur most frequently along coastlines, tides, wave action, etc., but we can occur in flash flood events as well. Damage from hydrodynamic forces is similar to that arising from an impact and occurs above the normal flood level. So you've got the flood level here, but then you've got wave action that's occurring up here. I mean, I remember we worked a large event out in Boston a few years ago. I mean, we were finding ocean spray and flood damage on the 3rd story. This is all from, hydrodynamic wave action, going up there. I mean, the surge was only, a few feet, but the dynamic flow of the waves caused everything to go up even higher. So you got to look at all those different factors. Velocity flow, again, it's discussed. Velocity flow is a part of this hydrodynamic side. Velocity flow results when moving water impacts a structure. It can cause isolated impact damage from floodborne debris at or near the flood line, unless you got a big boat, and then, it can be up on the roof line. Seen that too. But different from damage from hydrodynamic forces, that debris impacts the structure rather than the rapid impact of the water. Again, this is all aspects of the flood though. Flood brings it, nice big tree, nice big boat, neighboring house, slams on another structure. That's that's damage from a debris impact from velocity flow. Velocity flow generally occurs during rapid flood events, flash floods, not during widespread general flooding, i.e. Hurricane Harvey. We didn't see any, I don't say any, we saw very minimal to very little, hydrodynamic damage in Hurricane Harvey in Houston, right? Obviously, you had Port Aransas, Rockport, those areas. You had the wave action on the shorelines, undermining pillars and pilings and, some slabs and things like that. But it was minimal compared to like a Hurricane Michael. But all that to say, it can also occur if floodwater recedes rapidly. How does velocity flow affect structures? Well, the most common one is probably scouring and erosion around the foundation system. That water is rushing, it's moving, it's pulling soils with it. It hits something, water's always going to find a way around it. It hits the foundation wall, it hits the walls, it creates the turbulence, it moves the soils out of the way, it continues to erode and degrade, the soil, displace the soils underneath the foundation, the pilings. Go stick your feet in the sand and watch a wave come in. That displacement of the sand around your feet is exactly what can happen, in these velocity flow types of events. In extreme cases, velocity flow can cause lateral displacement of the structure and the direction of flow, particularly when accompanied by buoyancy forces acting on the structure. So you've got these combination of, hey, it's in water, pressure's being upward, and it's being hit from velocity flow to the side. That's kind of like the double whammy. So you've got a really fast flowing, flash flood event, or along a river, that's where you see true velocity flow damage, displaced houses, that kind of stuff. And then obviously you get when the embankments are eroded out on a river, and then you got the houses that are literally just falling into these rivers because the velocity flow eroded so much of that embankment soil. And now these houses are, they're no longer supported and they fall into the streams. So, types of damage from velocity flow, pretty obvious. Foundation piers leaning in one direction. You got a big old house up here. It's on piers. It's fine if the waves are going underneath the house and the water's going underneath the house. Well, as soon as that water gets high as the house, and now all of a sudden this house is acting as a retaining system or a big dam, it's not designed for that much water pressure as it gets higher and higher and higher. So you see these houses that are literally racked and leaning off. May have not collapsed yet, may have collapsed, just totally depends. Scour of soil around foundation piers, as I was talking about earlier, racking of structures, and then structure leaning in the direction of the flow. Hydrodynamic forces, here's some examples. Again, you've got one house that's leaning off to the side on the left side of the screen, and then on the right, now you're looking at all this erosion, all this undermining of these piers that's supporting this house. I think that's Hurricane Michael, if I'm not mistaken, but I'm not 100% sure. You've got hydrodynamic forces. Again, that's wave action. Washes out of roads, washes out streams. And there in the middle, you've got soils being washed out around the foundation. The same thing on the right. You've got that erosion. Now all of a sudden you've got a slab that's unsupported, that can cause cracking the slab, downward displacement of the slab. I mean, it's not being held up anymore. It really all depends on how much of that slab is being, how much that slab was undermined. And then that can translate all the way back, to the house. I mean, this kind of stuff, everything needs to be supported. It's construction, right? It's not supported, more damage happens. Go ahead, Jason. Looking at debris impact, pretty obvious. You've got the wave action, you've got all those trees, all that debris. Who knows what hit it up top there? That could have been that debris up top. That could have been a boat. But you've got, you got some serious damage here. The wind damage in this structure is minimal. The wave action and the hydrodynamic flood damage, that structure is substantial. Identifying it, again, impact damage to elevations facing the incoming flow of the waves, right? So you've got displaced siding facing the ocean. Pretty obvious. Impact damage across the entire elevation as opposed to localized damage. If it's one missing piece of siding, that's one thing. If it's the entire elevation of missing siding up to a certain height, it's a little bit more obvious on what's going on there. Damage above the flood line. again, with that wave action going higher than the flood line. Example of something in Hurricane Katrina. So as we talked earlier, hydrostatic, created by still water, hydrodynamic, created by moving water. It's dynamic, it's moving. Static, it's standing still, it's exerting pressure. It's the slow death versus the quick death, if you wanna put it in those terms. All right, go ahead, Jason. All right, so Jason's gonna take over here on soil inundation. Again, this is equally as important, guys, because this is what you'll see the most of, and it's really important to understand what's happening with soil inundation versus earth movement. So go ahead, Jason.
So soil inundation, Dan was mentioning Hurricane Harvey. There wasn't a lot of hydrodynamic. It was more soil inundation from standing flood water. So that area had water standing there and actually saturated those soils for an extended period of time. And it breaks down those soils underneath that home. And with the soils broken down like that, there is a lot of differential movement in those soils. So when that water table resides and goes down, you're going to see potentially some movement of that house. So you're going to want to reach out to an engineering firm and determine what that subsidence was. How does soil inundation affect structures? The voids in the soil and the architecture of the soil. Some of the soils, like Dan said, certain soils are affected different than others, like sandy soils as opposed to like loma soils. And when you bring in water to those soils, they are displaced differently. So for each individual area of the country, you're going to have different soil subsidences and movements. And actually, they could shift or move and crack. You'll see even tiles crack. You see in many areas from the different results of the settlement as that water dries out and subsides. And it's called differential settlement. And in this case, this is a situation where the water inundation subsided, and you'll see some of the cracking in the CMU blocks. And this is typical these CMU blocks as opposed to like regular reinforced concrete that holds up a lot better, but you will see it in some of the older ones as well, just based on the type of the soils underneath that are supporting those soils.
And Jason, I'll let you go back to that picture. I'm going to chime in here for a second. So one indication of differential movement is the vertical cracking, the stair-step cracking you see on the brick. If you don't have the undermining and the erosion underneath the slab, and you've got all these stair-step cracking, cracks at windows, cracks at doors, those types of things, you really have to look at what's going on in the soils. Because if you don't have visible erosion, visible undermining, all those types of things, like it's not like this soil's gone anywhere. It's just like walking in mud. It loses its load-bearing capacity. And the reason Harvey was so brutal on this was because there was so much water. That water penetrated so deep, it broke down those soils to depths that aren't typical during a flood event. Now, I mean, we literally saw houses displaced, 3+ inches from one side of the house to the other side of the house without a single thing of erosion or undermining, just because of the soil composition makeup and how deep that water penetrated. And that's just earth movement due to soil inundation. That's not erosion, that's not undermining, that's not pressure. That is just straight up, I can't hold this house up anymore. I can't hold up this part. And then it just starts to go. And we saw this to, extensive amounts in Harvey, more than I'd seen in any other event prior to, just because of the length and the depth and the time that water was there and present for.
Thank you, Dan. Differential foundation movement. What causes the differential foundation movement? We're just talking about that. Localized soil conditions, the inundation of water, and then localized loss of supporting soil. So this is more the erosion or scouring. This is the localized loss of supporting is the scouring, when there is a velocity flow, and it actually removes the actual soil from underneath the foundation elements, whether it's a slab or whether it's a pylon. It actually removes the soil, and then you could have differential foundation movement. And then you're going to have displacement of those soils, and actually that slab could drop, and you're going to have that situation above the slab where you're going to have the stair step cracks above. So this is all coverage questions. So when you have a situation, we don't want to get into coverage, but when you have the erosion piece as opposed to the soil consolidation, where the soils are so saturated and it dries out and you have the movement and settlement, that's where different coverage determinations come in. So we provide you with an expert report to make those determinations there. Two separately complete coverage areas: the soil consolidation, where you have the settlement and the displacement of the soils, as opposed to the loss of the soil support, the erosion, the evacuation of the soil, and the moving of the soils from the, whether it's scouring or wave action or the streams running through their rivers. How does differential damage caused by other forces? So following a flood event, differential forces could be localized damage, but often creates widespread damage throughout the structure. Inundation of soils with water can also cause hydrodynamic forces to increase on the foundation or basement wall, increasing damage to the foundation. So this is what I just discussed. The inundation, it will cause a lot of damage, like Dan mentioned before. When you have the amount of water sitting in one area and for an extended period of time, when that dries out, the soil shifts and moves, and it could cause extensive damage to the entire slab of that home. And it moves all aspects of the house. It causes cracks around the doors and windows. It shifts doors and windows so you can't even open them sometimes. The floors are unplumbed. If you place a ball on one side of the floor, it could be rolling. There'll be out of plumb walls and leaning walls. So there's a lot of damages caused by the hydrostatic forces of water from soil inundation. Scouring, as I mentioned, scouring. Scouring is like when you remove the actual dirt and water from under the foundation elements. And that downward displacement, as I mentioned before, creates all the internal damages, all the stair step cracks, the windows not being open and closed. Wave action creates a lot of this. If you have the hydrodynamic forces and you have constant wave action, you'll see these forces from these waves undermine these slabs over an extended period of time. Then you have the rivers constantly flowing around certain elements, whether it's a post or a corner, or even drainage from a gutter, an extensive, you have a downspout running next to a corner of a house, you'll have extensive erosion possibly from the constant scouring of the water moving across that certain area. When water is more turbulent and the velocity of the flow increases, the more soil and displacement you potentially could have with the downward displacement of these slabs or foundation elements. How does scouring differ from differential movement? So the differential movement, as I mentioned, this is where you have the water, the standing water there. The soils are so saturated. When the water table recedes, you're going to have that movement of that soil, as opposed to differential movement where you have the actual scouring and the erosion and the downward displacement where you have the foundation elements dropping, or the downward displacement, which causes the damage to the potentially entire home in certain situations. Mud flow, we see mud flows. When I was working with the corporate insurance companies, we ran into mud flows typically out in California, where I've seen a lot of this, where you had the wildfires. They burned a lot of the mountainsides, the hillsides, and then you have a heavy rainstorm, or you have spring flooding or snow melt coming off those mountains, and you have the rapid snow melt, which creates a muddy slurry of rocks and earth and other debris that starts rapidly forming like a mud slurry running down a river, or in some cases it ran down streets, and it forces its way into homes and crushes everything in its sight. So I know FEMA has some guidance on mud flow and landslides, which I'm also going to talk about. A landslide is where you have a solid landmass. When you have soil inundation that's heavy and a large mass of rock or earth just collapses, And we see this a lot, like in Beverly Hills, you have homes sitting up on those cliffs, and it's not a slurry or a liquefied mud flow. It's just more of a landmass collapsing to the ground from the side of the mountain. And that's due to a lot of soil inundation of water. So there is coverage for one and not the other. So if you're not sure of the situation on whether it's a landslide or a mud flow, we could engage a geotech, and they could help us make those determinations on whether it is considered a landslide or just a mud flow.
Yeah, and one thing on that too is, you could have a landslide that's triggered by erosion, not just the other way around. I mean, think about an embankment along a river. It might look like a landslide, but it really might just be due to erosion. And so instead of a denial, now all of a sudden you've got coverage. So you really got to make sure you're covering all your bases on this stuff, because what the ultimate end cause of this damage is what's going to determine, what happens with this claim and how the policy relates to, that end conclusion, on those engineers' reports. So you really got to make sure, that's why it's like, oh, it was flood did it. Like, as we said in the beginning, like, it's not, that doesn't answer the question. That's why you have to get into these nuances of like, what aspect of the flood did it? And you've got the forces, and you've got all these different factors that can work together, to cause the damage, so you could have a lot of things that might look like they're contradicting each other, but they actually flow, with each other, based on how it's done. So you always have to make sure you're really getting down to the bottom of it. And, I could say, I had a situation one time when I was a flood adjuster, and I ran a claim on the coast of Washington, and the guy, I called the policyholder up, and he's like, hey, he's like, when can you get here? He's like, my house is about to fall off into the ocean. And I'm looking at the satellite imagery of this thing, and I was like, what do you mean you're about to fall off into the ocean? Like, you're a quarter mile from the ocean. So whatever, I fly out to Washington, and I drive out to this loss. This thing is literally hanging off the cliff. And I'm like, wow, this is kind of crazy. So I actually, I thought this thing was like, all right, well, yeah, wave action acting on this thing, erosion of the coastline, boom, this thing's going to be covered. Well, they had to get an engineer involved because of the scope of the damage and all this other stuff. And what was interesting is what ended up happening was the end result from the engineering firm and the engineer that went out there was cyclical erosion of the shoreline, not a one-time event, which is true. I looked back at it, and he showed all these different dates. Like, that house used to be 2 miles from the ocean, and the ocean had just continued to do it all. And so the end result was there wasn't a one-time event that caused that. It was the gradual and ongoing erosion of the shoreline by the ocean that caused it. So the importance of all that, I mean, the implications are huge, both to, the carrier and to the homeowner more than anything. But you have to get to the bottom of those things. And I was thinking all along, as the adjuster, I was like, oh yeah, this is easy. This is just wave action. This will be a great, nice little claim. And then boom, we get the engineer report back, a few weeks later, and it's like, oh, whoops, like, this is not going to be that. So it's very important that you're asking the right things and looking at the right things, and not just assuming and getting down to the bottom of it.
So Julie, I will turn it back over to you, and Dan and I can take some questions from you guys.
Okay. I don't see any chat box. Does anybody have any questions? I can unmute people. Hold on.
Wendy does.
Okay, hold on, Wendy. I'm getting you.
Surprise.
Give me a second. I've lost my thing. Okay, hold on. All right, Wendy. For whatever reason, hold on. Okay, it's not letting me. Oh, you know what? Hold that thought, Wendy. I've got to run.
We can answer the one question that's up there right now while Julie's working on that. How is differential foundation movement versus flood cause compaction determined? Well, differential foundation movement may be the result of flood caused compaction. You know, that one's the result and one's a potential cause. Differential movement is the result of either erosion, undermining, or soil inundation breakdown. You know, as kind of alluded to in the beginning, like if you don't have any erosion, any undermining, any evidence of forces acting on this structure, and you've got slab cracks here, there, you've got, you know, the vertical cracking and all these other things, and you look at the soils report, the soils data shows clay, expansive type soils. You know, A plus B pretty much equals C when you're looking at and determining that. And so when you don't have all the things that would lead up to, you know, force of water doing what it's supposed to, then you're looking at a differential foundation movement situation due to, you know, basically long-term and ongoing, you know, more than likely long-term and ongoing, you know, movement of the soils underneath, you know, could have been exacerbated by, you know, the flood causing, immediate soil breakdown. But the reality is it's earth movement, soil breakdown, and it's not due to anything else. Wendy?
Hi, Dan. How are you?
Fantastic.
I'm so glad you guys are here. The presentation was great. You too, Jason.
Thank you, Wendy.
Can you guys hear me okay?
We do.
Yeah.
So I wanted to, first of all, your presentation was fantastic, very informative. And I know that we call on you as experts to make these determinations, but obviously it's not your responsibility to make coverage decisions. And so I wanted to just touch on a couple things that you said to make sure that our audience, our adjusters in the audience understand which of these situations would be afforded coverage under the flood policy and which would not. And the big difference, I mean, obviously something like wave action, where you've got a coastal front home, wave action comes in and knocks a house down, that's a flood claim. That's not really that hard to figure out, like you pointed out. But when we're talking about soil inundation underneath the slab or underneath the structure, I think the big thing that adjusters need to keep in mind is whether or not the flood actually took the dirt away. Did the flood remove the soil actively during the flooding event? So if you're talking about scouring, like you mentioned, and you showed some photos where flood water removes the soil from the corner or underneath some portion of the foundation, that type of loss would be afforded coverage. But in the soil inundation screen that you showed, Jason, that was a good slide that you had that shows the voiding of the soil underneath the buildings. If the soil inundation takes place, the flood leaves and the dirt compacts later, allowing the structure to settle, that is a differential settlement which is excluded under the flood policy. So just make sure that you understand the difference in those terms when you're reading your engineer's conclusions. If you have a claim, that you understand the difference between an active removal of the dirt by the flood event itself and the differential settlement that takes place after the flood is gone and the soil compacts or shrinks and then creates a condition that allows the structure to settle and become damaged. So that that's kind of all I had to say.
No, that's great. And yeah, that's what our hope was too. I mean, while Jason and I both come from the flood world, that's not our job now. So coverage is always up to you guys. You know, the best part about what we do is we've got the experience to make sure that the answer is definitive enough and covers the right basis so that you guys can make those decisions.
Yeah, and let me make it clear too that to everyone listening, both Jason and Dan and their team know the difference in coverage. It's just not their responsibility to draw a coverage conclusion, so you won't find that in their report. That's why it's important for you to know the different types of loss scenarios that they're going to describe and the conclusions that they draw. and then how you bring a coverage conclusion and recommendation into your own report. So it wasn't intended to suggest that you guys don't know you, but they're both very flood experienced before they got into the engineering side of the world. And I didn't want you to think that's what I was saying.
No, you're good. I wanted to clarify too, but because that is a good point. You know, we'll get hate calls from homeowners saying that, well, the adjuster said that the engineer said it wasn't covered. We have never said that.
That's right.
All right. Well, if there are no more questions, that concludes this episode of Flood News at Noon. Dan and Jason, thank you so much for doing this for us. I really appreciate it.
Love you guys. Can't wait to come see us sometime now that the world's opening back up. So thanks for having us.
Yes.
And have a great week.
All right. You guys too.
Thank you, guys.
Talk to you later. Bye.
Appreciate it. Bye.